Want to look a little bit more about polynomial division, and what I show here is a third order polynomial, a3x cubed plus a2x squared plus a1x plus a0, and I'm going to divide that by a first order polynomial, b1x plus b0. Another way of representing exactly the same mathematical operation is as a fraction as shown here, where we have the third order polynomial in the numerator and the first order polynomial in the denominator. So I'm going to write p sub 3 of x to represent this third order polynomial. Now we know from the theorems in algebra that the polynomial p3 of x here can be written as this first order polynomial b1 of x plus b0 times q of x, okay, and q of x is called the quotient, so we can write it as this times q of x plus the remainder. So if we were doing this long division here, the q of x would be the term we would get in the top of the division, and then we would get the remainder after we go through the process of the long division. So we can always write p3 of x as being the product of this factor times q of x plus the remainder. Okay, so I've already gone through and I've done this, and I gave this problem to you as a homework problem, so I expect you to have figured this out. And if you haven't, you need to go and figure it out. You need to show that when we do this division into here, that the term we get on top of the division symbol, the q of x term, is given by this thing right here. This thing right here is our q of x, okay? Now, the remainder, when we divide a third order polynomial by a first order polynomial, the remainder is given by this function right here, r, and notice that r is not a function of x. R is just a constant in this example. Now, the one thing that I really want you to look at is to see if you see patterns in these numbers. For example, looking at r, you see that b0 divided by b1 appears several times in that expression. And we get also a pattern here in that we have a term that looks like a2 minus 3t, a sub 2 minus a sub 3 times b0 divided by b1 times this. And then we get another term which has a1 minus b0 b1 over this. So here we have b0 b1 times a3. We have this expression. Then we get a1 minus b0 b1 times that. And then we have b0 b1 times that. So we get this sort of recurring pattern that appears in R0. I want you also to look for recurring patterns that appear in Q of X because I would like you to think about what this will look like if, for example, if we get a fourth order polynomial that is divided by a first order polynomial. So look at this, derive q of x and r, and then I want you to think about what you get when you do the division of b1 of x, b1 or b1 times x plus b0 divided into a fourth order polynomial, okay, divided into a polynomial that looks like a to the fourth, x to the fourth, plus a sub 3, x cubed, plus a sub 2, x squared, plus a1 x plus a0, a sub 0. Okay, you divide this into that, and if you haven't already determined what the pattern is here and here, then I would think you would definitely find out what the pattern is after doing this expression right in here. Okay, so until next time.